So far, we've talked about points and lines, but what we haven't talked about are planes. And I want to talk about planes and put this together with what we've learned about lines. So I want to talk about planes, and before I do that, you need to understand something about three-dimensional points, three-dimensional graphing. Now, what we've studied so far we've studied a plane, one particular plane, the XY plane. It's just a flat surface, and we can plot points. We have an X of 2, a Y of 3, and let me just put a 0 here for now, and I'll explain this in just a second. That right there is a point on the plane. And you know, we've had other points. We've maybe had -1, 5, and 0. Let me put that there. There we go. And you can see these points. Now, this has been the extent of what we've studied. We've just been studying x-axis, x-coordinates, and y-coordinates. But let's suppose we want to get some depth to this. Let's suppose I want to rotate this axis up a little bit here and add a z-coordinate. So notice we have an x-coordinate, an x-axis, a y-axis, and now let's suppose I want to put a z-axis on there. So instead of the point 2, 3, 0, maybe I'll put 2, 3, 4. And now notice there's a point out here in three-dimensional space. Let's suppose I want 2, 3, -4. Okay, whoops, let me put a negative, forgot the negative. There we go. And now you see there's a point down here. See, going in the -z direction. And all of these 3 points, they're all lined up right in line with the 2, 3, 0. But what I did was I just added, a z-coordinate. So we can plot z-coordinates. We can go through here and we can plot -1, -2, and 5 if I want to. And there's that point. So there's all of these points over here that we plotted in the XY or in the XYZ space. Now, what we can do is we can think about, now remember, a line is just a bunch of points joined together in the XY plane. So it's just a bunch of points joined together, and they form what we know as a line, just something straight. That's on the XY plane. But there could be other planes. Now let me just make a plane here for you. I'm going to do X plus Y plus Z. I'll say equals 4. Now look at that. There's a plane. Let me turn off these coordinates up here. Okay. So this is a plane. Now it's just a flat surface. It doesn't look like this. It's just, it's just a flat surface out here in space, and this is kind of an artificial cutoff here where it has it looks like a wedge or something. That's not what the plane looks like. There's just a plane out here in space, and there are points on this plane. Let me plot one. I'm going to plot 1, 1, and let's say 2. Now look at that. There's a point on this plane. See? And in fact, this plane is a collection of points. It's a collection of points that if you take the x-coordinate, you add it to the y-coordinate, you add that to the z-coordinate, that adds up to 4. And we call these ordered triples. So all of the points with an x, y, and z coordinate, those that if you add the coordinates up, they add up to -4, that's what this plane is. So there's another point. Let's look at this. Let me do -5, okay? And let me do this. Let me do 6 and 3. Now that, let me zoom out here. That's another point on this plane, and you can see it right there. Okay, So we've got these 2 points on the plane. Okay? Now, that is something that is just, we're not going to bother with how to get the equation for a plane or anything like that. But I do want to illustrate something here for you. Let's suppose I want a line that passes through those 2 points. Let's just suppose I want that. Now remember, in 2 dimensions, we need the delta x and we need the delta y. And we need a point. So look what I'm going to do here. I'm going to get the x part of this by finding delta x. So I'm going to do 1 minus negative 5. And I get 6. So I'm going to do 6t plus 1. And I'll go through this a little slower here in a minute. Okay. Then I do 1 minus 6. I do the y coordinates to get delta y. So that's negative 5 plus 1. And now for the z, I want to do a delta z. That's going to be the difference of the z's. 2 minus 3, that's negative 1 plus 2. And now look at this. I've got a line right there. Now, I need to adjust the t's. I'm going to make the t's go from like negative 5 to 5 to make that line a little longer. And there it is. Now look at that. That's a line on this plane in space. Right there. Okay? Now what I want to do is go back and go over this a little more slowly. Okay? So up here I've illustrated some things here. So look, here's what I've got. I've got 2 points, 1, 1, 2, and another point. That's A. This point I'm calling B is negative 1, 2, 3. And I'm looking at those plotted down on the XY plane. Okay? So if you just dig what I've got going on here, I've plotted those down on the XY plane. And I'm saying, let's just act like those are points on the XY plane, and I want to get a line that passes through those. I want to get the parametric form for a parametric set of equations, a set of parametric equations. So look what I need. I need delta x. So I go 1 minus a negative 1. That's 2. Delta x is 2. Now let me get y. 1 minus 2, that's negative 1. So now I have delta y. Now here's the way we can get the parametric equations for the line. I go delta x times t, there's 2t, plus the x coordinate, 2t plus 1. Now I'm going to do the delta y. Negative t, negative 1t, plus the 1 right there. This is a set of parametric equations for this line right here. A line that passes through these 2 points. Okay? Now, let's suppose I'm not satisfied with that. I want the actual line that passes through these points right here. In other words, in space. And these points happen to lie on this plane. See? 1 plus 1 plus 2, that's 4. See? Negative 1 plus 2 plus 3, that's 4. Those are points on this plane down here. This plane out here in space. Now, so we've got the x coordinate, the y coordinate, and the z coordinate. And here are those points plotted over here. See, I've got A here and B here. And I want to get a line that passes through those points. That's what I want. Okay? So we've already got delta x. We've already got delta y. Now it's time for delta z. Okay? So here I go. I take 3 minus 2, and that's the change in z. And I get 1. So I'm going to do 1t plus, and I think I was using this point right over here, A. Okay? So I got t plus 2. Now, what that will give me is this line right here. See? See how I've got these points? and then over here is the line. So this is pretty cool that we can get the equation for a line in space in 3 dimensions. See, you used to be limited to just getting equations for the line when the z component was 0. When you just had a non-zero x, a non-zero y, yeah, you can get a set of parametric equations for that line. But what about lines on a plane? Now, most geometry classes don't touch on this, but this is cool stuff right here. We've got a plane, and we're actually getting a line that's on that plane. So look, let's see how this works. Let's suppose we've got this plane. This point and this point are points on that plane. And I want to get a set of parametric equations for a line that passes through these 2 points. And it's on that plane. Okay? So look, first thing I need the delta x. Here it goes. 4 minus 1 is 3. Then I need the delta y. 7 minus a negative 2 is 9. Now the delta z. 9 minus a negative 6 is 15. So dig what I've got. 3t plus 4. Whichever, I can use either one of these points. I'm using this one because it's got the positives. I like the positives. Okay. Okay. So look at this. 3t plus 4. Okay. Delta y. 9. See, 9. 9t plus 7. And then finally, delta z. 15t plus 9. Look at that. And if you graph this, and I used Desmos on this one. You can use GeoGebra. Up here, I use GeoGebra for these graphs. And you can notice how the graph looks a little bit different. But down here, I'm using Desmos. So look, I've got the 2x plus y minus z equals 6. That's this plane. And then I plotted the 2 points. Here's a point, here's a point. And here is the equation for the line. And I had to change the values for t a little bit so I could get a broader perspective. Okay. The t started off going from 0 to 1. Well, I need more than that. I need more points than that. So here's what it looks like. And look at that. That's a line out here in space that you found. Now, here's the way it's going to go. To get an equation, a set of parametric equations for a line that passes through 2 points. Let's say these 2 points. You need a delta x, a delta y, and a delta z. And it doesn't matter which one goes first. You could say x2 minus x1 or x1 minus x2. But just be consistent. If you start taking values from b and subtracting values from a, do that for all x, y, and z. Okay. Now, here's what we have. We have delta x, delta y, and delta z. And now, if we want our parametric equations, the x part is going to be delta xt plus either this x1 or this x2. I used x1 here and x2 here. It doesn't matter which one. And then delta yt plus y1, delta zt plus z1. And that will give you the parametric, a set of parametric equations for the line that passes through those 2 points. Now, I've got an assignment down here, and what I'd like for you to do on this assignment is plot this stuff. You'll like Desmos the most. So desmos.com/3D. You want to /3D. Notice here I've got the /3D. So you need to do that. And then you can work through these. And what I'd like for you to do is go into Desmos and work through these problems and get your graphs, and then click on the share. Let me show you. If you come over here to Desmos, well, let me find the Desmos here. Here's Desmos. there's a share button over here. You see it right there. And if you click on share, you can say share your graph and then just copy that link. And then in the Canvas, for this assignment, there's a place to save your URL or upload a URL. So I'd like for you to do that. All right. Well, this won't be until, this is late next week, I think Friday. But anyway, I mean, you might be watching this Friday. I'm making these videos in advance. So today is, I think, May 29th when I'm making this. So, all right.